Good afternoon, this is Schweitzer. We're going to look at factor label or conversions of units within the metric system. So this is going to be kind of a twofold type idea. One, we're looking more at, again, can I use factor label, which is going to be, I always spell label wrong. I'm not sure if that's right, but either way, and then also, can I get familiar with the metric system? So how does the metric system kind of work here? So in this situation with this guy here, the metric system has what they call a prefix, and then they have a root. The prefix isn't always there, but the prefix tells us the magnitude of the value, like how big or how small is the value. And then the root tells us your type of measurement. Okay, whether you're measuring length, mass, volume, or what have you. So my prefixes are listed kind of right here, and this from kilo down to milli. This tells you how big the number is. And then the prefixes are based off of these guys here. Now, our prefixes for mass would be a gram, liter, meter, and we've mentioned this for the English unit already, but for energy, the corresponding unit to a calorie is a joule. This guy is symbolized as a little g, little l, or just a plain stick L, or liters, meter, and then just a J for joules. Alright, so let's take a look at our next slide to look at more like how do I generate an equivalency off of this thing. So everything is based on tens. Unlike the English system, which has really random equivalencies, everything's based off tens. Even still, in the United States, we may not be super familiar with some of these terms, and some of them are very obscure, meaning that we won't use them very often. So let's just say my base unit is a meter. Okay, so that means there is 1 meter in 10 decimeters, or there are 10 decimeters equals 1 meter. So 1 meter equals 10 decimeters. Now I'm creating equivalencies here. This equals that. I could put it as 1 meter over 10 decimeters, and they're the same. In this situation, 1 decimeter equals 10 centimeters. So 1 decimeter equals 10 centimeters. You should realize now that 1 meter equals 100 centimeters. So when I put those together, 1 meter equals 100 centimeters. Okay. And then 1 centimeter equals 10 millimeters. So 1 centimeter equals 10 centimeters. So it's all this 10, 10, 10. But of course, if 1 meter equals 10 decimeters and 10 decimeters equals 10 centimeters, or 1 decimeter equals 10 centimeters, then we get this 100. And therefore, 1 meter equals how many millimeters? And I wrote that down incorrectly, millimeters. So in this case, we go one step farther, that 1 meter equals 1,000 millimeters. Okay. So again, reading this thing is somewhat important, but there's generalizations that should be made that are being used all the time. We use the base unit very commonly, and we use the extreme units very commonly. Deci and centi, very rare. A decibel, for example, in sound intensity is used there. But I can't really mention any other places that we use a lot of these units. Now, centimeter is also kind of common. Okay. So what do we do here? Well, essentially, you should realize that every step is a power of 10. So I could make it a sort of summary to a student who's really trying to figure this out, that each step, okay, is another 0 on your equivalency. So from the top all the way to the bottom is essentially 1 kilogram, let's say, equals how many milligrams? Well, it's 1, 2, 3, 4, 5, 6. So 1 with 6 zeros. So that is something that maybe a general student just really trying to get a grasp on this equivalency could use to find that out. Another thing that I tend to tell kids that a good thing to have in your brain or memorize would be that it's 1,000 to the outside. So one of these guys is 1,000 and 1 to 1,000. That's a really common thing that we use. So 1 kilometer equals 1,000 meters. 1 meter equals 1,000 millimeters. 1 kilometer equals 1 million millimeters. Okay. I've just come up with 3 equivalencies that are extremely common. It wouldn't matter if I was using a meter, by the way. I could be using grams or joules. 1 kilojoule equals 1 million. Now that would be 1.1000000 millijoules. Okay. All right. So that's just setting up equivalencies. That's pretty common. Now we have this beyond here is the micro and the nano. This whole thing comes in steps, and let's just take a quick second and just mention that we just do powers, basically thousands at this point. Every time you step, you do 1,000. And this is something that we'll do some of. But if you don't see one of these for a while, you may need to investigate and re-establish where that unit is or how you figure it out or look it up. So 1 to 1,000. So, for example, 1 meter equals 1,000 millis. 1,000. That's 1 e to the third millimeters. 1 meter equals, that's 1,000. Okay. 1 e to the sixth micrometers. That right here is 1 million. And of course, give myself a little bit more room here. 1 meter equals 1 e to the ninth nanometers. And that would be another set of zeros on this value. Hopefully you're seeing that 1 e to the ninth is another way of just saying 1 times 10 to the ninth power. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's kind of how we set up this relationship. We could maybe try an example of this as we get towards the end. Alright, so metric system examples. 250 liters to milliliters. Okay, so I'm just going to, because of this stair step, I can jump from one thing to anything I want in one equivalency. Whether it's 10, 100, 1,000, it's going to be some of one of those guys. So I'm going to go from liters to milli. Okay, so it's one step. 152.0, that's 4 sig figs. Liters, get rid of liters and go to milliliters. Okay, what's my equivalency? Let's look at our stair step here. And I'm going to go from my base unit of liter to milliliters. 1 large liter equals 1,000 small millis. Okay, so 1 large liter equals 1,000 smaller milliliters. And my answer is 152,000. Alright, think I got that. And right, that's it, or liters. And I have 4 sig figs here. I have 4 sig figs here. I want 4 sig figs here. 1.520 E. Alright, so I'll move this thing over all the way to the end. 1, 2, 3, 4, 5. E to the 5th. Okay. Double check your math on that guy. 152 times 1,000 equals 150,000, and that would be correct. 1.52 e to the 5th is 152,000. Okay? And of course, remember that's a liter right there. If this has 4 sig figs, this has 4 sig figs, we kind of ignore this as being perfect in the middle here. Alright. The answer got larger. Lots of small millis equal 1 big liter. Okay, milli to kilo. So I'm going to go from the bottom all the way to the top. And of course, that's a million. A million smalls equal 1 big. Alright, let's try this out. 25.0 milligrams, dot line, get rid of milligrams, and go to kilograms. 1 to 1 million. And we're going to divide. So 25 divided by 1 million is 0.12345, like that, and 0. So now 1, 2, 3, 4, 5. If I want to show sig figs, I can leave it just like it is. I need 3 sig figs here, and I have 3 sig figs right here. I could also write this as 2.50, 1, 2, 3, 4, 5, e to the negative 5th, and it would be in kilograms. Again, there are lots of examples in our workbook that you can try to make sure you're proficient. Watching me do one example does not make you proficient. Alright, cups to gallons. Now again, we recognize this is the English. So I got to get back to those converters. So let's do a quick review of that. I'm going to go from cups to pints, and I'm going to jump right to gallons because I know there's 8. So in my mind, when I do this, I'm looking at that conversion. It's 2 cups, alright, to 1 pint, and there's 4 pints to 1 gallon. So I know these equivalencies. If you don't know them, look them up and make yourself a little plan here. Let's do it. 2,000, dot 0, that's 5 sig figs, dot line. This is in cups. Get rid of cups and go to pints. Get rid of pints and go to gallons. 1 pint, 2 cups. 8 pints, 1 gallon. 2,000 divided by 2, divided by 8. Holding in the end, we have 5 sig figs. 2,000 divided by 2 divided by 8 equals 125. 125, I want to hold 5 sig figs because I have 5 sig figs here. That's 0.00, and that is gallons. Alright, gallons to teaspoons. I'm going to give myself a little bit more room here. I'm just going to have to run all the way from gallons to pints to cups. It's going to be all the way down to tablespoons to teaspoons. I'm not sure why I got to pick such a long one, but let's do it. 150 gallons. That's 2 sig figs. Dot line, get rid of gallons. That was weird. Gallons to pints. Get rid of pints and go to cups. Get rid of cups and go to tablespoons. Get rid of tablespoons and go to teaspoons. 1 to 8. I made that one up because I know 2 of them. 1 to 2. 1 to 16. That's an unusual one. And 1 to 3. And again, you can just imagine how much more difficult this is than the metric system. I'm not going to bother mathing this out. You can do it if you'd like. So, are there any conversions between English metric? Absolutely. And you could look up many other ones, but I'm just going to give a couple of common ones. Mass 2.2 pounds equals 1 kilogram. 3.78 liters equals 1 gallon. 2.54 centimeters equals 1 inch. 4.18 joules equals 1 calorie. And these are, something good to put in your note card or to keep somewhat on task. Alright, so here we go, English to metric conversion. So let's make a plan. It's all about the plan. How much do you weigh in kilograms? Okay, so Mr. Schweitzer weighs about 200 pounds, lbs. So I'm going to go, I got to get out of the English world into the metric world. So I'm going to use, what do I got here? This conversion here goes from mass right to kilograms. So I can use this equivalency in one step to get from where I am to where I want to go. So I'm going to go pounds right to kilograms. I have that equivalency. Here's my work. 200 pounds. Get rid of pounds and go to kilograms. 2.2 pounds equals 1 kilogram. So I weigh 200 divided by 2.2 equals 4. 200 divided by 2.2 equals 90.9 kilograms. 90.9 kilograms. A 5,000, so I got, here in this case, if I held 3 sig figs, then I would have 3 sig figs here. So I don't know how closely I measured that, but if I have to go 201 sig fig, then this is just going to be, well, it would be 90. It would be 90. Right? That'd be 1 sig fig. I have 2 sig figs here, and I'm running it through. Okay, gallons to milliliters. So I got to get from gallons over to metric. And let's look at that conversion. What do they give us here? Gallons to liters. Now again, you might have access to a relationship that gets you from here right to here in one step. I don't have that. You're not going to have that on a test necessarily because you don't have the internet. At least at your fingertips, typically speaking. So I'm going to go from gallons to liters, because I have that provided in the previous slide. And liters, I can jump right to milliliters. Alright, and I know that that's 1,000, and this is 3.78. So I have that kind of on my desktop of my brain. Let's go ahead and just calculate it. 5.0 e to the third. Get rid of this is gallons. Get rid of gallons and go to liters. Get rid of liters and go to milliliters. 1 gallon is 3.78 liters. 1 liter is 1,000 milliliters. These are exact relationships, so I have 2 sig figs here, I want 2 here. Let's calculate this out. 5.0 e to the third. Okay. Now the next slide I'm going to talk about a little bit closer to how we got this or how we use that, scientific notation. But some people are better at that than others. Times 3.78 times 1,000 equals, alright, I got a pretty big number, 100, 189, and then I got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So that would be, looks like 18.9 million. 1.89 e to the 1, 2, 3, 4, 5, 6, 7th, e to the 7th, and then I have my, I want 2 sig figs here, so I need to get one less here, e to the 7th. Okay, so that's going to knock that down to round it up. There's my running line, 1.9 e to the 7th, and that would be unit of milliliters. Okay. So really straightforward when we look at this sig fig stuff. The really thing you got to know is what the sig figs you start with should be the sig figs you end with. Alright, so again, how do these bigger units work? Okay, I mentioned it earlier on that these are just thousands. 1 to 1,000, 1 to 1,000, 1 to 1,000. So that's 1 to 1e to the third, 1 to 1e to the sixth, 1 to 1e to the ninth. Can you use your calculator properly? You use that double E button here. You do not use that little caret button. That will only get you in trouble. Eventually, you'll have issues with this. So let's try this here, kilometers to inches. Okay, here's gallons. Using scientific notation. Again, I've used a bunch already, but you just move over 1, 2, 3, 4, 5.5 e to the 1, 2, 3, fourth, negative fourth. Okay, this guy here. So kilometers to inches. All right, so let's think of the plan here. Okay, I'm gonna go kilometers to centimeters and centimeters to inches. I have conversions for those. This is my standard bridge from length to length. So dot kilometers, dot line, get rid of kilometers and go to centimeters. Get rid of centimeters and go to inches. Now technically all the work's been done already. The brain stuff's done. Plug the numbers in and calculate. 1. Now how do I go about this guy? Let's go back to that stair step and see if I can figure out what we got here. I'm going from top to bottom. That's a million, but I'm not going all the way. So I'm going from top just minus 1. So rather than being a million, I'm one step short. So it's 1 to 100,000. So 1 to 100,000. And then 1 inch is 2.54 centimeters, which is provided on the previous slide. I am not going to calculate this out. You can. Make sure you have 2 sig figs in the end. Gallons to liters. Okay, so this happens to be a straight conversion. 2.5 e to the fifth. Again, that's just using that guy right there. Dot line, get rid of gallons and go to liters. 1 gallon, 3.78 liters, and I have my answer. I'll calculate this out here. 2.5 e to the fifth times 3.78, and I get 945,000. Okay, and this is in liters. So in scientific notation, it would be 9.4. I want 2 sig figs. That's going to round up 9.5 e to the 1, 2, 3, 4, 5, e to the fifth. Okay. A couple examples there again of showing scientific notation. Thank you very much.